Hi, I'm Roger Howe, and I'll be introducing the next speaker, Tom Lee. And Tom brought an awful lot to Stanford. He got all of his degrees from MIT and worked in industry at Analog Devices and Rambus, with that obviously having connections to our department. When he came, in 1994, he started the Stanford Microwave Integrated Circuits Lab, which is abbreviated SMIrC. I don't know exactly how that maps, but that would show you a little bit of Tom's sense of humor. Since then, he's helped create the field of RF, CMOS, integrated circuits, and various branches, won many awards, many Best Paper awards, and also contributed to industry, having co-founded several companies, Matrix Semiconductor in particular, and then to round it off, went to DARPA for a couple of years to run the Microsystems Technology Office in 2011 and 2012, and lately has been continues his active research. His most recent paper I found was on epidermal electronics. This is something like a tattoo, and the issue was transmission line modeling of this stretchable antenna. So we look forward to hearing, Tom, what your perspectives are on your long view and interest in history. If you haven't visited his office, it's actually a branch of the Tech Museum with many interesting artifacts. So the curator.
Excellent, we're on the air now. The topic of this talk is actually the result of a series of questions I kept on getting when I first joined Stanford. I would give talks different places, and they would say, forget about all that new stuff. How can we create Silicon Valley where we live? You know, they think, okay, well, we'll just take some money, we'll throw that at the university, and then goodness happens. And this experiment's actually been tried, and MIT did a study that they published a few years ago that essentially 100% of these efforts had failed around the world. And there's lots of hand-wringing about, you know, why was this such a big failure? Was it not enough money? Are schools not good enough? What do we have to do? So to try to answer the question, I looked into the history of this place, and I found that there was a lot missing in the standard narratives. And perhaps you might find something of value. If not, go ahead and keep snoozing. The postprandial coma is a very good thing to enjoy. But the standard origin story looks something like this, that there's this guy named Fred Terman, the father of Silicon Valley, or the grandfather, or some patriarchal figure, encourages his students, Bill Hewlett and Dave Packard, to start HP. That's very great. And Terman also encourages interesting character Bill Shockley to come back from Bell Labs and establish a semiconductor company here. But he turns out to be kind of a lunatic manager, and so his unhappy employees go off and start their own companies, and Fairchild happens, and then Intel, and then, cue the music over the credits, Silicon Valley happens, and a choir of angels sings. So that's a standard origin story, and I guess factually those things are kind of true, but they don't really reveal the story of how this place came to be. I mean, why was all this stuff possible on this slide? Well, so we go back further in time, and you all have time machines, by the way, installed at your table. So I'm pressing the remote now. We'll be going back in time to around the turn of the previous century. It turns out, and we'll find this together, the actual story is, not surprisingly, not linear, extremely complex, and has huge elements of just complete chance. So that should make us pause a little bit. The Valley actually has reinvented itself many times. So it's not just a single Silicon Valley story, it's multiple threads that somehow people have elided into one gigantic story. So let's take a look at exactly how all that happened. It started with a cosmic ray hitting chromosome number 19 in just the right place. And this guy named Frank McCarty comes out 15 years later. He's a self-taught high schooler who decides what the world lacks and what the world really needs is the ability to talk wirelessly over the phone. At that time, there's wireless, but it's spark on and off keying Morse code. So it wasn't for ordinary folks. So in 1905, he manages to convince a banker in Oakland to fund a company based around this idea. How does that happen? Well, you have to be nuts to give that kind of money to this kid, but there were plenty of those people around. This is gold rush country. So here's the patent. that was awarded, was filed just a couple of months before the big San Francisco earthquake in 1906. And there he is adorning the cover. Here's a cover story of San Francisco's boy inventor. Here he is, boy genius. Look at the halo around his head. I mean, his brain is radiating smartness waves. It's really quite impressive. So there you have it. We've never heard of Frank McCarty. You mention Frank McCarty to anyone except the guys at the History Museum, and they go, who? And you say, well, you know, he sort of gave us the very first high-tech company in Silicon Valley. And they go, not Hewlett and Packard? No, it's actually decades before. So the reason we didn't hear of him is that he unfortunately died in the chaotic aftermath of that earthquake. He got run over by horses, and that was the end of teenage Frank. So the investors are, of course, they're crushed, but they don't want to say goodbye to the dream. So they come over to Stanford, and they ask Harris J. Ryan, the first EE chairman, they say, Professor Ryan, we lost boy genius. Can you give us another boy genius? And he says, sure, no problem. We have a freezer out back in the hills. And, write us a big enough check, we'll thaw one out, and, no problem. And so they do that, and they thaw it out. And you can notice there were some side effects. But Cyril Elwell shows up as the new boy genius, and he takes over the cause, and he works on it for a couple of years, and there's success of a sort. He's actually able to make the apparatus work, and in fact, work well enough at low enough power that he was able to complete a 2-mile wireless phone call on the streets of San Francisco by 1908. Now, you might have heard of this guy named Marty Cooper, one of the founders of the cell phone, going around the planet bragging about him making the very first mobile telephone call in 1971. Well, sorry, Marty, this guy trumped you by more than a half century. The bad news is that as much work that he had put into it as he did, it was never going to be scalable to make a business out of it, because the SMIrC technology that was the basis for all this would not allow you to have private phone conversations. Everybody would hear everybody else. Not very good for business. So he said, unfortunately, the best you can do is never going to be good enough. And so they were very depressed, of course, and they all committed suicide. No. And so but the company folded, and Boy Genius said, but wait a minute, there's more. So the investors listened. He says, I've been reading journals. So you students out there who don't read journals, take note. So there was this Danish inventor, Valdemar Poulsen, who had been playing around with, of all things, glowing carbon rods. Why? I don't know. He was not like the other kids. And apparently, glowing carbon rods were the first electric lights, but they had a very strange VI characteristic. They had a negative resistance region. And Poulsen actually sought to exploit that to make oscillators. Great, and he figured out a way to make them oscillate at the unheard of frequency of 100,000 cycles per second, faster than you can count. So that's infinity. So he thought this was going to take over, and unfortunately Marconi had gotten there first and locked up sort of all the governments and industrial contracts, and so Poulsen was locked out of this. So he was suffering with a great technology but no business. Perfect. Mr. Supplier of Solution, please meet the person who's suffering with a need. And so Elwell manages to negotiate with Poulsen for the rights to this technology and brings this ARC technology to Silicon Valley in 1909. A new company forms out of the ashes of the previous McCarty Wireless Corporation. First Stanford president David Starr Jordan sort of arranges a syndicate of VCs. He gets the civil engineering chair to kick in some money if there was a promise of hiring his son. And so got him a job. Stanford alumnus Beach Thompson joined in. He was now the head of a utilities company, was a forerunner of PG&E. Don't hold that against him. The Crocker family, who had made money in silver, the Comstock load boondoggle, well, not boondoggle, actually, it was a very successful thing, and a mysterious syndicate of Chinese investors who are believed to have been called the Six Companies, but we're not quite sure. But anyway, we'll just go with that because it's an interesting name. It sounds like a gang. So they start this company based around the ARC technology, which had the attribute of not spreading their spectrum all over the place. It actually allowed one-on-one private communication, and that was what their goal was. Luckily, there was another genetic mutant who worked at this company, a guy named Leonard Fuller, who came to the company actually to do due diligence. The family wanted to invest in this company, and they sent their son, who had apparently a degree in science. And he asked them questions that were so probing, they offered him a job on the spot. And after he accepted, he discovered why they were so interested in hiring him. Turns out they had just hit a brick wall. They had been scaling up from small to larger and ever larger powers by simply multiplying all physical dimensions of the transmitter by a factor of 2. And they were rewarded by this for a while by having the power output double each time. It's a nice Moore's law thing going on. So of course, there's Moore's law and then there's Murphy's law, which trumps all other laws. And what happened was they had demonstrated a 30,000 watt transmitter to the Navy. The Navy, on the basis of that demo, gave them a contract for a 60,000 watt transmitter. So they go back to the lab, they double all the dimensions, and what they ended up was just a big, heavy, but still 30,000 watt transmitter. And so they asked Fuller, you got this degree in, what is it, science? Can you maybe fix this? He said, well, tell me your scaling laws. Oh, very simple. We replace 1 inch by 2 inches. And he said, no, really, what's your method? And he said, that's really our method. So I said, oh my God. So he said, do you mind if I use math and physics? And he said, oh, that sounds great. Physics, yeah, that's good. You do some of that. So he did a lot of that, and he figured out what scaled linearly, what scaled quadratically, what went logarithmically, and he was able to figure out how you could build a transmitter of arbitrarily high power, limited only by patience and capital. And it was judged to be so earth-shattering and epoch-making that Stanford conferred its first EE degree, doctoral degree, to Leonard Fuller. And then it was very rapidly placed with a top-secret clearance necessary to read this document by the Navy. So it remained actually a classified document until after World War II, when people got around to say, oh yeah, this doesn't apply anymore. So it was very hard to get his thesis for a long time. So not too bad. And then, of course, later on, he lost his mind and went to Berkeley as EE department chairman. But that's okay. The story ends happily. He regained sanity and came back to Stanford, where he finished out his career. But a little bit more about that later. But here's Arc Alley's first VCs. You won't see any reference in the literature to Arc Alley because I just made it up. But if some guy could make up Silicon Valley, I'm allowed to make up another name. So I we call it Arc Alley. So there's President Jordan, there's Bill Crocker, there are the 6 companies. I was amazed to find a photograph of the 6 companies. Charles Marx, and apparently Beach Thompson, the PG&E Forerunner guy, was very shy. I could not find a photograph of the guy anywhere. I couldn't find a caricature, I couldn't find a sketch. He's just a cipher. He may not have existed. But anyway, his name is there. So there is the humble beginning of Silicon Valley. That's Arc Alley. It's a building at the corner of Channing and Emerson in Palo Alto. Right now, it's a parking lot, and there's a California historical marker that says, here is the birthplace of Silicon Valley. One of 3 markers that I'm aware of that say, here is the birthplace of Silicon Valley. So for those of you out there afflicted with the geek mutation, here is a drawing of the ARC transmitter. It looks nothing like anything that anyone in this room has ever worked on. It's this big canister filled with hydrogen gas, carbon pointy thing touches copper not pointy thing, big old magnet, and then lots of amps from the power company, and somehow RF comes out of it, lots and lots of RF. And as I say, they scaled this weird thing up to ridiculously high powers. Federal has a distinction of the following attributes. It was the first VC-funded electronics company in the Valley. It was a magnet for geeks west of the Mississippi. If you had the geek mutation, you suddenly sort of felt this pull toward California, and you find out that, well, it was centered around Federal. So this allowed us to aggregate from the entire population that tiny minority of us afflicted with the geek gene. That's a good thing. Well, I know opinions differ, but it's a good thing. At Federal, people like Lee DeForest, who invented the device that would convert us from ionics to electronics by inventing the vacuum tube. He had invented it in 1907, but he had no idea that it did anything until 1912. Very curious, that's a different story, but it's true. In 1912, Federal beats out Westinghouse and GE, these gigantic, well-connected East Coast concerns, for the contract to build the Navy's global communication system. That's amazing. It's a tiny little company that most people on the East Coast felt, California, don't they have like gunfights every noon on Fridays? And, when the guys in the saloon get a little too much? Well, yeah, it's true, but still, they also had geeks. Fred Terman interns there in 1922. And later on, he would say he learned an awful lot about how not to run a business by watching Federal do its thing. Future Texas Instruments founder Cecil Green works there, as well as Charles Litton. So a lot of important DNA sort of gets established right there at Federal. So here is when they're about to ship a 500,000 watt transmitter in 1917. So we're used to Moore's law with transistor shrinkage. Here's Moore's law of just gargantuan growth in the power of transmitters. So in 8 years, they go from the prototypes that you can see on the table in front of the gentleman to the thing behind them. It has a 60-ton magnet behind it, and that was made here. It was housed in a warehouse somewhere in Menlo Park. There's Leonard Fuller on the left, looking surprisingly dour, considering they just managed to pull off this amazing technological feat. I suppose that maybe the thing isn't working quite yet, but they had to take the photograph. Well, all was not great. One reason we don't know about Federal today is that they disappeared. And one reason they disappeared was having built the global telecommunication system for the Navy, there was no need for a second one. So they had difficulties. But geeks, having moved out here, decided, well, we still need a roof over our heads. We'll invent stuff that other people will pay us for. And so immediately startups start to form. There's this wonderful diaspora out of Federal. Federal disappears into the bowels of ITT, which turns out to be the endpoint for a lot of technologies from Silicon Valley after their heyday. But in 1931, Fuller is reminiscing about the good old days with one of his friends and mentions, now that he's at Berkeley, that he's got this young, super bright physicist who wants to build this thing called a cyclotron. But there's no money in the depths of the Depression for the 60-ton magnet that he needs. And the other guy says, Leonard, don't you remember we have a 60-ton magnet sitting in a warehouse that we're paying for storage? You go, oh my God, that's right. So they arrange for it to be donated, and it's a happy ending because Ernest Lawrence then wins the 1939 Nobel Prize for his cyclotron. There's a second story that goes with that that's not as well known. His mother is diagnosed with inoperable fourth-stage cancer shortly after this. And he and his brother, who was an MD, approach Mom and say, you know, we have this crazy idea of maybe bombarding you with radioactive particles. How about it? You know, we might kill you painfully, but... And Mom said, sure. Turn the beam on. Why not? What have I got to lose? She outlived her son. They cured her of her cancer. So from Federal to life-saving therapeutics, I think that's a pretty cool coda to this. Magnavox, a trademark that still exists today, was founded by expats of Federal. Pridham and Jensen. Jensen went off to have his name attached to a speaker company. These are trademarks, of course, that live on today. So here's Lawrence and PhD student Stanley Livingston standing in front of this thing. Again, from their grim expressions, the cyclotron is not cyclotroning yet. But it's still a gorgeous thing, and you can recognize the magnet. It looks just like you'd imagine. Magnavox built us things like audio systems, which are ordinary objects today, but they didn't have an audio business back then. There were no amplifiers. Well, they made the first ones. And Woodrow Wilson gave a speech which was powered by one of these early ones. It was a couple 100-watt audio system, and it caught fire just as the president was about to take the podium. And Pridham reached in and just grabbed hold of the thing that had the most flame near it and pulled out the vacuum tube, and there was redundancy. There was parallel vacuum tubes, and it stopped the flame. The president was not killed, and Magnavox lived on. So if you were an audio geek, this is what you lusted after. This is what you want to show off to your friends. You know, ooh, wow, 2 ebony horns of audio goodness. That was just great. Geeks love it. The television story also, interestingly enough, intersects Silicon Valley at an early time. Again, another young mutant, Philo Farnsworth, a Mormon farmer boy, comes out of Utah, has this idea for electronic television. They tell him, keep going west until you end up in Silicon Valley, San Francisco, because there are crazy people there with money and not as much brains, and also geeks that you can hang out with. So he sets up shop to Green Street, and there was a picture on the left that came out of some history book, and I took a picture of what it looks like a couple of years ago. It's pretty much the same. Hasn't changed very much. So the technology keeps changing, but the building apparently has stayed pretty much the same. And you notice Bill Crocker was in here again, writing checks to this kid with a nice, crazy idea. Terman ended up advising Farnsworth and also hooked him up with a lot of bright Stanford grads and faculty. And so the television becomes a reality here in San Francisco, in Silicon Valley. And in 1927, they had their first success transmitting this out-of-focus image of Farnsworth's wife. And within 7 years, they have the studio equipment, they have the transmitters, they have the receivers, they have the cameras, they have everything set up, and they demonstrate it at the new Franklin Institute in Philadelphia. There's another wonderful story. The Varian brothers, they were local boys. They lived down kind of near Morgan Hill. They walked all the way to Stanford. And one was a physics guy with a severe case of dyslexia. It took him a little extra time to get out of this place because reading was just a torturous thing for him, but he just stuck it through. And his brother was a pilot who learned how to fly by buying a World War I surplus plane for $25 and jumping in after having read a pamphlet on how planes work. And as he later wrote, the liftoff was not a problem. It was when he realized he had to actually land. And so he kind of found an open field and plowed into it. He fixed the plane, got back in, did it again, kept on doing it until he learned how to land properly. So these are the kinds of people who helped build Silicon Valley. Not deterred by the crashing part, but just loving the lifting off part, he said, Russell, you're the smart kid in the family. I would love to be able to fly in any weather. Can you build some widget that could see at night and through fog and rain? And Russell said, that sounds like a good problem. I'll work on that. And he eventually invents this thing called a klystron, which allowed you to generate huge amounts of microwave power in a very compact form factor. And it ended up showing up just in time to help save the Battle of Britain. It was small enough to be put in every airplane, and it allowed the Allies to multiply the effectiveness of their, at that time, very, very small air force against overwhelming Nazi superiority in the air. And so it saved England, and there you have it, that widget down in the lower right-hand corner, that was their prototype, the first one that actually worked. The company they formed after the war, Varian Associates, is actually the first tenant of the newly built Stanford Industrial Park. HP would be second. So finally, we get to the part where H&P show up. It's been now 30 years plus since Federal and McCarty, and finally Hewlett and Packard show up in the story, and I think this part's fairly well known to people, but there's Bill and Dave, and there's the portable box, which displaced refrigerator-sized monoliths that existed beforehand, with which you could use to test sound systems. So it was a desktop revolution from mainframes to desktops. It happened here first. The first big customer, of course, was Walt Disney Studios. Walt Disney loved stereo sound, or wanted stereo sound for his new movie Fantasia, and the only company on the planet that had equipment that would allow him to test the quality of the projectors in actual theaters was Hewlett and Packard. So there you go. So Disney, Silicon Valley plus Hollywood equals goodness, and there you have it. The dancing hippos, improbable in terms of physics, but still entertaining to kids. Terman goes to war and plays a key role during World War II. He heads up this thing called the Radio Research Lab at Harvard. Radar was being developed down the street at MIT. And the idea was that Harvard was going to be the red team. They were going to be the stand-in for the Axis powers. Because the assumption was you can't maintain technological superiority indefinitely. Someone will inevitably find and exploit a weakness. So let's find it first, and then come up with a countermeasure. And so their job was to screw with MIT, which is kind of a natural thing for Harvard and MIT, so that played into their inclinations that already pre-existed. And so the RRL was dedicated to electronic warfare, as we now call it. And Terman was wildly successful, and he gets noticed by the bigwigs. And Terman was not one to pass up an opportunity because he had done a calculation and noticed something that he felt was not quite right. MIT, Harvard, Caltech, and Columbia had received about $250 million of funding during World War II. He looked up Stanford's share, it was $50K. He said, hey, wait a minute, that's not right. So he worked very hard to convince the bigwigs that they should not overlook Stanford, that we had a lot of talent here, and that in fact we could be sort of the electronic intelligence arm of the military, and that they should definitely write some checks and send them out this far. And so when he comes back and heads up the EE department and becomes a dean, he brings with him 11 of the brightest RRL faculty that he had worked with during the war, and they formed a core of the post-war folks who pivoted Stanford toward sort of defense electronics. So Stanford quickly becomes a leader in electronics intelligence, and thanks to a spigot that now had opened wide, funding flowed quite freely towards Stanford. We had a core of very, very bright, energetic faculty determined to make a difference, and Terman worked consciously to create an ecosystem of innovation, which set the stage for what was to come next and what we now call Silicon Valley. But nothing specific was planned by any of these people. It all happened by accident. What Terman did was he just created a stage that was amenable to bright ideas and to take root in the minds of smart people. And so I'll pass now the baton to Jim Gibbons, who will tell you how that next stage happened, but I'll just leave you with a couple of thoughts. We should be very grateful that genetic mutations do occur with a non-zero frequency. The role of chance in aggregating together a critical mass of geeks should leave us humble. It doesn't happen everywhere. And this is something that I had to note with the folks who kept on asking me, how do we create Silicon Valley? I said, well, first, generate mutations, and two, find some way of bringing them together. And that's going to be an important part. And I think that if you were to go back in time and just change a couple of initial conditions, we would end up in a very, very different place than we actually ended up. So the movie of history doesn't repeat itself. It's chaotically sensitive to small changes in initial conditions. But we should be happy. The geek gene is certainly strong. And the geeks are here now. And they have to eat. They have children. I know it's remarkable, but true. And so we are going to create solutions to problems, and if we don't have problems to solve, we'll make those too, and then solve them. So hooray for mutations, hooray for geeks, and hooray for you coming and lasting this long talk. Thanks.